So today we're going to talk some more about inverse functions and relations. And really we're going to focus on the concept for finding an inverse of a function. And there's 4 steps that I refer to when we're talking about inverses of the function. The first one is replace the f of x by y in the equation. So it doesn't have to be f of x, it could be g of x, it could be h of x, it can be j of x, whatever the name of our function is. Then we're going to interchange the x and y. We didn't like that idea of reverse, so interchange the x and y. And what that means is we're going to switch places. X is going to go where y went, y is going to go where x went. Then a third step is solve for y. It's our littlest statement up here, but it's the one that requires the most work. And then finally, we're going to put our function back in function notation, which if you recall, it's f to the negative 1. That negative 1 on the f says that we are working with an inverse. And here is how, when we look at these first 3 examples, we're going to see a strong illustration of how to find an inverse. Once again, following the steps up there above. First step, instead of writing f of x, we're going to write y. That's our first step. Nothing else changes. Step 2, switch the x and y. Interchange the x and y. Reverse the x and y. However you want to think it. X is going to go where the y went. Y goes where the x went. Nothing else changes. Third step, solve for y. Well, we're going to subtract 3 from both sides. And we get x minus 3 equals negative 2y. And finally, like I said, we're still in step 3. We're solving for y. So it's negative 2 multiplied by y. So we need to divide everything by negative 2. And we have x minus 3 over negative 2 equals y. And then for step 4, what I usually do is I just right beside that, put that notation. F to the negative 1 of x. Maybe saves a step from writing the whole equation again. Although I do want to say, on this particular problem, that's not the only way to write the answer. Because remember, sometimes what's going to happen is we would be graphing this equation, so we would want it in slope-intercept form. I am happy with the way that we just wrote it, but it could be x divided by negative 2 minus 3 divided by negative 2 equals our inverse. By the way, what happens when we are subtracting a negative? Minus a negative gives us plus positive. Either one of those answers is fine. The second way is more for when we actually have to graph the function, which we're not focusing in on today. There's the first example. Let's see a couple more that maybe are a little bit more straightforward, but still following those 4 steps that you have at the beginning of your notes. First step being, instead of g of x, write y. Step 2, interchange the x and the y. X is going to go where y went. Y goes where x went. Nothing else changes. Well, sometimes on these problems, the fractions cause an issue. But what I'm going to recommend is that we move the 1 over to the other side, first of all, because now we're in the process of step 3, which is solving for y. And we have x plus 1 equals negative 1/5 y. But again, the fraction is what tends to cause people the trouble. Well, in our denominator, in the bottom of our fraction, we see a 5. Let's multiply this side of the equation by 5. And if we multiply the right side of the equation by 5, we need to multiply the left side of the equation by 5 also. And that means the entire left side we need to multiply by. And what that does for us is that gets the fraction to cancel out. The 5's cancel out. And we're still left with 5 times x plus 1. But over here, these 5's canceled out, and we have negative 1 y. No more fraction, which is a relief to many students. And we can finish this problem. We're still in the process of solving for y on step 3. We're going to distribute. We get 5x plus 5 equals negative 1y. Well, it's negative 1 multiplied by y, so we are going to multiply by y. We're going to multiply by negative 1, so we're going to divide by negative 1. And the nice part on this one is we can divide. 5 divided by negative 1 is negative 5x. And another 5 divided by negative 1 is negative 5. And we just finished step 3. And step 4 says use your inverse notation. And there's our inverse notation. Steps, I hope, are helpful. As we move on to part C, it's the same process. Instead of writing h of x, we're going to write y. That's step 1. Step 2, switch the x and the y. X goes where y went. Y goes where x went. Nothing else changes. But if you're going to have any issue on these problems, it's probably the fact that there's a fraction in here. And once again, if you look at the denominator, the bottom of the fraction, we see 2. And we can multiply the right side of our equation by 2. But if we multiply the right side of our equation by 2, we're going to multiply our left side of the equation by 2 as well. And what happens when we multiply the right side of the equation by 2 is that those 2's cancel out. And now we're left with 2x equals 7y plus 18. Again, we're still in the middle of step 3, which is to solve for y. So to solve for y, at this point, we're going to subtract 18 from both sides. and we have 2x minus 18 equals 7y. And lastly, it's 7 times y. Our inverse operation is to divide by 7. So we end up with 2x minus 18 divided by 7 equals y, which is also in inverse notation, h to the negative 1 of x. Good steps to follow when you're working on your practice here in a little while. But there's a relationship between a function and its inverse, and it's going to go back to composition. So here's a previous topic now that we're going to be able to apply. And what we're going to do is we're going to simplify f of g of x, and we're going to simplify g of f of x. And remember, f of g of x and g of f of x can be written with all parentheses, or they can be written so that it looks like fog, but it really isn't fog. It's f open circle g of x, g open circle f of x. They all mean f of g of x or g of f of x. So as we look at example number 2 here, we're given 2 functions. We're given f of x equals x plus 5, and we're given g of x equals x minus 5, and we want to figure out what does f of g of x equal. And as we start this, remember we're going to start with what does g of x equal? So we look up there, we see, well, what g of x equals is it equals x minus 5. And we're going to take that value and we're going to put it back into the f function. Well, our f function is x plus 5. We're going to take this value and put it back in here for the x. So it's x minus 5 plus 5. Notice that we have some like terms. We have a minus 5 and a plus 5, but what does negative 5 plus 5 equal? 0. So negative 5 plus 5, they cancel out and we're left with x. So there's our f of g of x. Over here in part B, same kind of thing. This time, however, we're going to start with f of x. We need to fill in what f of x equals. And f of x equals x plus 5. We're going to put that back into our g function, which has a value of x minus 5. And we're going to take this value and we're going to put it back in here. So it's x plus 5 minus 5. And once again, we have very similar circumstances. We've got positive 5 minus 5. What does positive 5 minus 5 equal? 0 again, and we're left with x over here also. So as we look at the question at the bottom of our paper there, it says, what is the result of both compositions? Well, both compositions in this case ended up to be x. Let's try another one. If we flip over our paper. Same set of circumstances, different functions. We have f of x equals 1 half x plus 3. G of x equals 2x minus 6. And we have the f open circle g of x, which still means f of g of x. And in this particular case, we're going to take g of x, and we're going to identify that value. And g of x in this particular problem is 2x minus 6. So I'm going to put that back into our f function. Well, our f function is 1/2 x plus 3. And usually 1/2 doesn't cause too much trouble. But if you need to use your calculator, use your calculator. We're going to take this 2x minus 6, and we're going to replace that green x with that value. So it's 1/2. Instead of writing x, we're going to write 2x minus 6 plus 3. And that's going to require us to use distributive property. We're going to distribute the half. 1/2 times 2x. Well, what's half of 2? 1. And what's half of 6? 3. And then we have plus 3 again. So we have minus 3 and plus 3, kind of like our minus 5 and plus 5 that we had in the last problem. Negative 3 and positive 3 cancel out to be 0. And over here in part A, we ended up with x again. Let's go the other direction. G of f of x this time. Well, we need to fill in what f of x equals. And what f of x equals is 1/2 x plus 3. I'm going to take that value and we're going to put it back into the g. And as we look above there, what does g of x equal? Well, it equals 2x minus 6. The 1/2 x plus 3 is going to go back in for our function over here. It's going to be 2 times 1/2 x plus 3 minus 6. We're going to have to distribute. And once again, if you need to use your calculator, use your calculator. 2 times 1/2 is 1x. 2 times 3 is 6 minus 6. Well, x plus 6 minus 6. There are those like terms that are opposites. And positive and negative 6 add to be 0. And we get x. Which means, like the previous problem, what is the result of both compositions? We get x. So far, it looks like two functions are inverses. If and only if f of g of x equals g of f of x equals x. Well, let's try one more. Two problems gives us a good indication that that's true. 3 is better. We look at one last problem here. It does show that the following functions are inverses. This time we don't have any hints. But the process is still going to be the same when we set this up. We're going to have to figure out, well, what does f of g of x equal? We'll start there. That's what's been our part A on the previous two examples. So we're going to fill in g of x, and we end up with negative x plus 1 divided by 4 is going to go back into our f function. And our f function is negative 4x plus 1. So that means that that blue value is going to replace that x there. So we have negative 4 and negative x plus 1 divided by 4 plus 1. So a reminder, we've got a 4 up top. We have a 4 in the bottom. What happens is these 4's cancel out. But be careful, because the 4's canceled out. 4 divided by 4 is 1, but that negative did not cancel out. It's still there. And we have negative x plus 1 plus 1. We're trying to simplify. We're looking to see, will this, when we completely simplify, end up to be x? Well, we can distribute. Negative times negative is positive x. Negative times positive is negative 1. I have the wrong color there, but, and then we've got a plus 1 over here. Well, does x minus 1 plus 1 equal x? Yes. So we have a good start on that. But we need to go both directions. So f of g of x is what we just came up with. We now need to do g of f of x. So we're going to fill in the f of x this time, which is our negative 4x plus 1. Negative 4x plus 1. That value is going to be put back into the g function, and our g is negative x plus 1 divided by 4. So we're going to take this value, and we're going to put it back in to this x there. Hard for me to draw my arrow in there. But watch out, because even though I need to separate this here, we get negative. And then we have our x value, which is the negative 4x plus 1. Then we have plus 1, all divided by 4. And we're going to have to distribute. The negative is going to get distributed here and here. Negative times negative is positive 4x. Negative times positive is negative 1. Plus 1 divided by 4. Don't skip steps on this. And I know that sometimes you think of this as a bad word, but this is kind of an algebraic proof. There's the bad word for some of you. We're proving, so to speak, that these are inverses. So our next step to look at is the fact that negative 1 and positive 1, they cancel each other out. And we still are left with 4x divided by 4. And then we can finish by canceling out these 4's, and we're left with x. And once again, that's what we were looking to determine. Does the fact of f of g of x equal g of f of x, do they both equal x? And they do.